You designed a beautiful 8-layer stack-up. Impedance is dialed in, materials are selected, and your fab house comes back with a list of manufacturing issues. Or worse, they build it and you get warped boards after reflow. Most designers optimize for electrical performance and forget that the stack-up also has to be physically manufacturable. Today, I'm walking you through 5 DFM checks that catch what your fabricator will flag before you send the Gerbers. The PCB Stackup generator has a DFM validation tab that runs these automatically on any stackup you generate. The number one cause of board warping is an unbalanced stackup. The tool compares top half thickness and bottom half thickness. If they differ by more than 10%, you get a warning. For a single core stackup, it splits at the core. Multi-core splits at the midpoint. This applies to any stackup with 4 or more layers. Copper weights matter too. The rule is simple. No more than 2 unique copper weights across your stackup, and external copper should be at least 80% of the average internal copper thickness. If you have half-ounce copper outside and 2 ounces inside, that thermal expansion mismatch will stress the board during reflow and thermal cycling. The tool flags both issues as warnings with the exact thicknesses and percentages, so you know exactly what to fix. Your fab has physical limits, and the tool checks every layer against manufacturing standards. For copper, minimum is half an ounce. That's about 17 microns, or 0.7 mil. Below that is too thin to plate reliably. Maximum typical copper is 3 ounces, at roughly 105 microns, about 4 mil. Above that, you're in heavy copper territory. Drill wander and etch compensation become real problems, and you need to confirm trace and space rules with your fabricator. For dielectrics, minimum thickness is 2 mil, 50 microns. Between 2 and 3 mil, 50 to 80 microns, is a yellow zone. At nominal limit, consider increasing for margin. For prepreg, the finished thickness after lamination compression matters. If it lands below 2 mil after press, that's a manufacturing risk for resin starvation. These aren't theoretical limits. They're the exact thresholds your fab's process engineers check when they review your stockup. This is the check that trips up the most designers, especially on thick boards or HDI builds. Aspect ratio is die depth divided by drill diameter, and your fab's drilling equipment has hard limits. 3 types, 3 limits. Through-hole vias, max 10 to 1. A 63 mil board needs at least a 6 mil drill, about 160 microns. Laser-drilled micro vias, max 1 to 1, strict because of laser depth of focus. Mechanical blind vias, max 3 to 1. Depth-controlled drilling has tighter tolerances than through-hole. Here's what makes this powerful. When the tool detects a violation, it doesn't just flag it. It calculates the minimum drill size needed and looks for a standard drill size that resolves the violation. If it finds one, it auto-adjusts the drill and marks the issue as resolved. You see the original drill, the adjusted drill, the original aspect ratio, and the final one, all in one card. Click the card and you get a full technical breakdown. Via technology, drilling method, board thickness, and whether the adjustment resolved the issue or if you need to make a design change. If you're mixing materials, say FR4 for inner layers and Rogers for RF layers, the tool flags it as a hybrid stackup. Different materials have different CTE, different lamination temperatures, and different scaling behavior. Your fab needs a first article run to dial in the process parameters. This shows up as an informational note, not an error, but ignoring it can cost you a full respin and weeks of delay. 5 checks: stackup balance, copper distribution, layer thickness, via aspect ratio, and hybrid materials. The DFM validation tab runs all 10 rule categories automatically: errors, warnings, and design notes, with specific recommendations for each violation. Run them before you send your stackup to the fab house. Check the show notes for the PCB Stackup generator to run DFM validation on your stackup before you fab. Now go build something your fabricator actually wants to manufacture.